Hello, today we're going to be looking at transformations, specifically translations and rotations. As usual, we're going to start with a little bit of vocabulary, so let's start filling in our blanks. So the pre-image is a figure before you have been done any kind of a transformation, whereas the image is the figure after the transformation. Now, specific types of transformations, the ones like we're going to be looking at today, they are called isometries. These types of transformations are also called rigid. Spelling. This is a transformation in which the shape, size of the pre-image remains preserved. In other words, we're just going to kind of scoot it around on the paper, change its position. But if one side is 4 squares long, it's going to stay 4 squares long. If the size of the object changes, but the shape is preserved, then it's called a non-rigid. Now, I know we haven't talked about it, but I know you've seen it in other classes. A non-rigid transformation might be something like a dilation, where stuff gets bigger. Okay, let's slide on down and fill in a couple more blanks, and then I'll show you exactly what I'm talking about. So a translation is a transformation in which each point of the figure moves the same distance and direction. So all the points move right, all the points move up, all the points move down. A translation creates a congruent figure. So this translation is an isometry. Okay, so let's take a look at our first one of these isometries. So for the first two of them, we're actually going to write the coordinates out. We're not going to do that on all of them. This is just to make sure you get what's going on with the coordinates. So I'm going to start down here and write down the coordinates for the original or the pre-image picture. So using the graph that's provided, I have -3, -4 for y. I'm sorry, for m. For y, I have -3, 0. For g, I have 0, -2. All right, so now that I have those, I'm now going to do my translation. So this says it's 2 units to the right and 5 units up. So you literally are going to take each point. I'm going to start with y because it's up here at the top. I'm going to move 2 to the right, and then I'm going to go up 5. So that'll be 1, 2, 3, 4, 5. So it'll be right up here at the top. I call it a little y prime because it's not the original. And I'm going to do that with all of the points. 1, 2, 1, 2, 3, 4, 5. That'll be m prime. Then I've got g, 1, 2, 1, 2, 3, 4, 5. And that'll be my g prime. I connect these back up just like that. As you can see, it still has the same triangle shape. I'm going to go ahead and write down the coordinates for each of these new points. But that's why it's called a rigid transformation, because my picture did not change shapes. Down here at the bottom, it says, what is your rule? Okay, the rule is pretty easy. You put in an x and a y, and the transformation you're going to perform on it is you're going to add 2 to the x, that's the right 2, and you're going to add 5 to the y, that's that up 5. That's all there is to it. We're going to do it a couple more times just to make sure you got it. Then I'm going to flip over to the other side and we'll do some reflections, but that's kind of it. So if you would like at this moment, pause the video and write down Q, L, and U. I'm going to fill those in right now and then hit play when you have had a chance to do that. Okay, so I have my points done, and now I'm going to do my transformation. So this says left 1 and 3 down. So left 1, 3 down. I'm going to call that U prime because it's my next U. Then I'm going to go left 1 and 1, 2, 3 down. That's going to be my Q prime. And left 1 and 1, 2, 3 down. And that's going to be my L prime. So there are my new shapes. If you need to, pause for just a moment on the video and write down your new coordinates. Turn it back on when you're all set there. Okay, time for the rule. So the rule is if I take my original point, x comma y, I am going to be doing the following things to it. I'm going to be taking left 1 and I'm going to be doing 3 down. Notice that the left and rights go on the x and the up and downs go on the y. Okay, so that's kind of how this works. Now we're going to do a couple more on this page just so you can see it where we don't write down the coordinates, but I think you're going to have the hang of it real quickly. So first let's look at our rule that's up here. Our rule says it's x minus 2. That means I'm going left 2 and I've got a plus 6 on the y, so it means I'm going up 6. So now I'm just going to take every one of those points and I'm actually just going to sit there and move those things and relabel the points. So starting over here, I'm going to go 1, 2 to the left and then 1, 2, 3, 4, 5, 6 up. And that's going to be my J prime. 1, 2, 1, 2, 3, 4, 5, 6. That's going to be my E prime. 1, 2, 1, 2, 3, 4, 5, 6. There's my M prime. And 1, 2, 1, 2, 3, 4, 5, 6. And I'm going to come over here. And that is my X prime. Please don't forget to redraw your shape. Your shape should be the same shape and size because it is an isometry. Now, I am not going to do number 4 because I think we've kind of got what's going on here. But if you would like to see it, I will come back and do it at the end. Let's flip to the next page. Okay, so our next page involves reflections. Now there's a bunch of different kinds of reflections. It decides on, it depends on what you decide to reflect over. So a reflection is a transformation in which a figure flips or reflects over a line of reflection. Now that's going to vary, so you need to make sure you're paying attention to what your line of reflection is. A mirror image is created. The reflection creates congruent figures, so a reflection is an isometry. There you go. Okay, so I am going to grab a different color just so it stands out. We are going to be reflecting across the x-axis. So my x-axis is this axis, the one that's right here. I'm just going to kind of make it stand out a little bit. That's all I'm trying to do, just make it stand out. What if you don't want to do that? You don't have to. It's okay. It's okay. Some of us see it. Now, let's start by writing our coordinates for our original problem. If you need to pause it for just a moment so you can write those down, go right ahead. I'm just going to go ahead and list them out. So I got -1, -1. I've got -4, 0. I've got -3, -5. Okay, here's how I do reflections. I ask myself, how far is the point from the line I'm reflecting across? So since this is dead on the line I'm reflecting across, then lo and behold, my new point will be dead on the line I'm reflecting across. Now, I is a little more exciting. It's one space away, so I'm going to reflect I to the other side. See, one space, one space. Now, X is a little bit farther, so it's 1, 2, 3, 4, 5 spaces. So I'm going to go from the line 1, 2, 3, 4, 5 spaces. And that is my x prime right there. And I'm just going to redraw my figure. And it should look like a perfect reflection across that line. Now, if you want to, go ahead and write out your coordinates. I'm going to do that right now for my new points. Then I've got -4, 0, and then I've got -3, 5. Okay, so let's talk about our rule on this. Take a look at I and I prime. So the x coordinate stays the same, but the y coordinate changes signs. Your x coordinate stays the same. Well, 0 is not a great example. Let's move on down to x. Notice that all it changed was the y coordinate. So my rule for this is if I put in any point, here's what's going to happen to it. The x will stay the same and the y will change signs. Done. That's it. Let's do a few more of these because we're going to reflect across several different options and then we're kind of done. Do make sure that you pay attention to reflections across all these different areas because they're going to be a little bit different. Okay, everybody, so let's go ahead and let's get these coordinates down for this. By the way, I'm using the same triangle for both of these, so you can just copy those coordinates right over to make it a little easier on yourself. Okay, so this time we're going across the y-axis. So I'm going to make my y-axis stand out a little bit for you. So there it is right there in the middle. And just like last time, I'm going to be counting places between the y-axis and where I'm going to my point. So this point I is 1 space away from the y-axis, so I'm going to go to the other side, and that's going to be where I put I prime. W is 1, 2, 3, 4 spaces, so I go the other way, 1, 2, 3, 4 spaces. Notice I'm keeping it on the same height when I reflect across the y-axis. X is 1, 2, 3 spaces, so I'm going to go 1, 2, 3 spaces to get my x prime. And then I'm just going to redraw my figure, which should look like it's just a reflection, almost like I just flipped it over. All right, now go ahead and write down your coordinates for those points. I've already done that earlier, so I'm just going to go ahead and write them down now. Okay, so how do I figure out my rule? Take a look at your two I's. The only thing that changed was the sign on the X. Look at your two W's. The only thing that changed was the sign on your X. Look at your two X's. The only thing that changed was the sign on the X. The Y value stays the same. So my rule, X comma Y, is -X comma Y. And that way I can do any shape that I want with a reflection. Now, I don't want you to sit there and think, oh my God, I've got to memorize tons and tons of rules. Instead, I want you to think about you can use the coordinates to figure out what the rule is. But if you want to memorize them, you can do that. All right, so now we're going to be doing a reflection over a different line, not one of the x-axes. So the first thing I'm going to do is, again, identify what I'm reflecting across. All right, so there is the line I'm reflecting across right there. And so now I've just got to get every point to an opposite position. So I'm going to start by writing down what my original coordinates are. If you want to pause right here so you can give it a try on your own, you certainly can. Or you may say to me, you know, I kind of already know how to write coordinates. That's not where I need help. And I understand. Okay, so let's talk about what this reflection is. Basically, your triangle is kind of cut in half. These 2 points are going to go down here, and this point's going to go up there. So from this line, I see that C is 1, 2 spaces down. So I'm going to go 2 spaces up. And I'm going to put my C prime right there. All right, R is on the top of the line and it's 1 space up, so I'm going to go 1 space down, and that's going to be my R prime. My V is 1, 2, 3 spaces up, so I'm going to go 1, 2, 3 spaces down, and that's going to be my V prime. And then I'm going to reconnect everything. And kind of coolly, it looks like you have reflected across a different line. So it's just a matter of counting. Please go ahead and put down your new coordinates for all those primes. And then we're going to see what changed. Okay, so let's look and see what changed. So if I look at these coordinates, the x's stayed the same, but my y value appears to have changed. My v seems to have changed, like just the y value. The c, just the y value seems to have changed. So what exactly has happened to those values as you're taking a look at them? Well, what's happened is the following rule. Oops, I gotta write x first. X comma y. So of course, as you can see, all my x's stayed the same, so I'm not changing those. But what happened to my y's? My y's were changed to a negative, and then 4 was added. So let's make sure that that rule works. So I went from 3 to 1. So if I make that a negative 3 and I add 4, I get 1. 5. Make that a negative 5, add 4, I get negative 1. So that's what happened on that. Sometimes they're kind of weird like that, and you may have to play around with it a little bit. Okay? Why did I make it negative? Because it is a horizontal reflection. So notice back over here when I did a reflection across the x-axis, that was a horizontal reflection, I make my y negative. But once you make the y negative, you got to figure out plus or minus what to get it to the right spot. Okay, let's go try another one. This time we're going to do reflection across the line, x equals 1. Right, so I'm just sliding it down a little bit so I can make that bolder. All right, please write your original coordinates. Okay, so there are my coordinates. Now I'm going to be reflecting horizontally this time. Okay, so I'm going to look at each point and I'm going to say how far is it from my reflection line. T is 1 space to the right, so I'm going to go 1 space to the left, and that's going to be my T prime. R is 1, 2, 3 spaces from the line of reflection, so 1, 2, 3 spaces. Sorry. 1, 2, 3 spaces from the line of reflection. So there's my R prime. And L down here is 1, 2, 3, 4, 5. So 1, 2, 3, 4, oh no, 5. Okay, let's redraw our figure. All right. Please go write your new coordinates. So I'm going to scoot this up. I'm going to write my new coordinates in. If you want to try this and pause it, you're certainly welcome to. As you can see, we don't have a lot of notes left, so it's not like this is going to be a super long video if you want to pause things. Okay, so let's talk rule. So first thing, I'm going to write my x comma y, and then I'm going to draw my arrow. Now, because this is a horizontal reflection, not vertical, I know I have to start by making a negative x. And I also know I'm not going to be changing my y at all. Now, here's the deal. If you make your x negative, so I make that to a negative 2, you have to say to yourself, what do I need to add to make that to a negative 4? So first you make this negative because it's going to be a horizontal reflection. So now I'm sitting at a negative 2. Oh, okay. Looks like I'm feeling like I'm going to have to subtract 2. I make it a negative 4 and then say, what do I have to do to get to negative 6? Yep, it's definitely minus 2. Okay, so when you're doing a horizontal reflection, that's left to right side, you are definitely going to need to change your x coordinate to a negative and then find what your plus or minus. If you're doing a vertical change like this one was, we're going to make our y negative and figure out what we have to add to it. All right, we got 2 transformations left. These are absolutely my favorites. These are across the line, y equals x, and its corresponding option. So first thing I'm going to do is I'm going to draw my line of reflection. Okay, so there's my line of reflection. Now, this is a little bit harder to do, okay, a little bit harder to do because you have to imagine that you're going over to the other side. So if I take a look at this, to this line, I have 1 diagonal and a half. So 1 diagonal and a half. So it's not just squares. I'm thinking diagonals because this is diagonal. So when I go to the other side, I'm going to go a half a diagonal and 1 diagonal, and that is where S prime will be. Okay? In this case of P, I am 1 diagonal away, 1 diagonal. So I'm going to go 1 diagonal to the other side. Okay, look at J. J is 1, 2 diagonals, so 1, 2 diagonals. Oh, that's not a J, that's an I. Okay, and now let's look at W. 1, 2 and a half diagonals, half a diagonal, 1 and a half diagonals, 2 and a half diagonals. Okay, let's redraw. Wow, there's my new figure. Now, I didn't put my points on. Let me go put my points on here. Again, if you want to pause and do them yourself and not watch me do them, I totally understand. Okay, and I'm going to go put my points on here, and then we'll be able to see really nicely what our change is. Okay, so look at that point comparison. How did that change? We've switched our x and our y. How did that change? Switched our x and our y. How did that change? Switched our x and y. Oh, another x and y change. So when I write my rule, I will write x comma y turns into y comma x. Ta-da! So not too bad. Okay, so our last piece of our notes is the reflection of y over the line y equals negative x. Okay, I've got to turn my paper sideways because that line comes down like that. So there's my line. Okay, unlike last time, I am going to go ahead and write down my coordinates. So that I will have them available. Let's see here. I've got -5, comma, -1, -2, comma, 3, -2, comma, 1, -4, comma, -2. Okay, so again, you're reflecting across this line. I'm going to be thinking about how far do I need to reflect to get to my new points. So if I look at this, this is maybe like a quarter of a square to go from the line to the W. So that would be W prime. Kind of like that one. That one was nice. All right. To get from the line to the I over here, I had to go half. Wow, that's kind of like a weird angle there. So I'm going to have to like go like way up over here, and it's going to have to go a little bit off. So let's see here. 1, 2, 3, 4. And that's almost going to be like right up here-ish. Yeah, it's going to be like over here. S. S is pretty easy to do. S goes over here. And my P isn't too bad. I mean, I can just kind of like run it over here. It's, you know, it's, gosh, it comes in like right about here. I don't know why I keep writing that as well. Let me just write that. Okay. So let's connect everything up. Oh, I think I went a little too far over that way. So we'll take a look at it when we actually get the points. Now, our coordinates on this, I'm going to have 1, 5. Yeah, I think I went a little too high on that. Let me redraw that little piece there. I'm going to do it with highlighter just so it'll stand out. So let's see here. It's supposed to be 1 and 5. So it should have gone to there. Okay. And then my P should have been a little bit more over a little bit, I think. Well, it's not too bad. Yeah, it should have been a little lower. I went a little too far out. Okay. Now, let's get those correct. So 1, 5. And then I've got, this one would be 3, -3, 2, and -1, 2, and 2, 4. All right, so let's talk about the rule for this. This is I think in my opinion, this is the hardest rule. This is actually the one that I kind of just memorize of all the rules, just because I find it to be the hardest. So on this one, because it is a diagonal, you have to swap your X and your Y, but because the slope of the diagonal is negative, you literally flip the numbers and you flip their signs. This is the only one out of the group that I actually go through and like think about it as something to memorize, just because I think it's really easy to get these guys messed up, especially the ones that are really far away, because unlike this side where you could like just count the diagonals, these are just really kind of challenging. So that's kind of like all of your notes on reflections and transformations. On the other side, you'll see that there's problems for you to do. Notice you do not have to write the coordinates. Okay, you don't have to write the coordinates. It does ask you to write a rule. So this one says, graph the image of the figure using the transformation given and write a rule. So you do have to write a rule for it. There are some problems on the back side. Please do not skip them. Here are 2 more. Down here, these don't have pictures, but if you want to draw a picture, you certainly can. But again, you may just want to use the rules like we've kind of talked about them. Like, for example, if you're doing this one, is it really necessary to use that? No, because you have a rule and you could just say to yourself, oh yeah, I'm going to have to swap my X and my Y's and change the sign on all of them. So I'll leave that up to you how you choose to do it. The key for this is on teams. And again, I am sorry I could not be there with you today. And I hope you all have a really good afternoon and an amazing weekend. Remember that next week is spring break. Make sure you pay attention to when your last quiz or test is before the break. And I'll see you all on Monday.